So our first unit is vectors. And a vector is a mathematical quantity used in physics that also has a direction. So for certain things like force, velocity, acceleration, displacement, momentum, and others, it's important that we have a direction associated with the size. So for example, if I had some block of mass m, maybe it's on a frictionless table, and if I had a force of 4 newtons to the right, and I had 3 newtons to the left, what's going to happen when I add those two vectors or add those two forces that are acting concurrently or the same time on that mass? Well, this is 4, this is 3. We can easily see that the resultant means the answer, is going to be 1 newton to the right. Likewise, let's take my same mass again, but let's say I have 4 newtons going to the right, and I also have 3 newtons going to the right. Well, now when I add those two together, because they're acting in the same direction, now I get 7 newtons. So when I have parallel vectors acting concurrently, it's actually pretty simple. If they're in opposite directions, the vectors subtract, and if they're in the same direction, they add. So the rule for parallel vectors is that they add and subtract. Now, sometimes we have vectors that are 90 degrees apart. I might have 3 newtons going towards the top of the page, if I use force as an example again, and I might have 4 newtons going off to the right. Now, if it's being pushed 4 newtons to the right and 3 newtons up, it makes sense that the resultant force is going to be somewhere in between the two. But we can't just add and subtract like we did before. We have to perhaps do the math. And one way we can do this is use Pythagorean theorem. C squared is equal to a squared plus b squared. So in this case, c squared is going to be equal to 3 newtons squared plus 4 newtons squared. So c is going to be equal to the square root of 3 newtons squared plus 4 newtons squared. And I already know that this is going to be a 3, 4, 5 right triangle, but I could put this into my calculator and I'm going to get 5 newtons is the answer here. So that's the magnitude of the force when 3 newtons and 4 newtons act concurrently, and they're 90 degrees to each other. And now I have to find the angle. So looking at my triangle here, usually we reference the angle to the positive x-axis when we drop in a Cartesian coordinate system. And so we're going to use trig. And so theta is going to be equal to the inverse tangent of the y over the x. So in our case, theta is going to be inverse tangent of 3 newtons over 4 newtons. And so we can go ahead and put that into the calculator. So we have 3 divided by 4, inverse tangent, and you can see that we get 36.9 degrees. So theta is 36.9 degrees. And usually we would write that as 5 newtons at 36.9 degrees. And another way in which we can add vectors that are not parallel to each other is to add them graphically. And there's 2 methods, or really the method has 2 names, the parallelogram method or the tip-to-tail method. So if I take my same example, if I have 3 newtons, and then going to the right, I have 4 newtons, I want to move these vectors so they're tip-to-tail. I can move the 3 newton vector provided I don't change its size or direction. So I could slide that 3 newton vector over here and draw it over here, 3 newtons. And I'm going to cross this one out so I don't get confused. And so now I have my vectors tip to tail. So here's the start, here's the end. So my resultant vector, maybe I label it R, is going to be from the base of the 4 Newton vector up to the tip of the 3 Newton vector. And then my angle would be this angle here. And so if this was an actual problem where I was perhaps given these vector lengths here, I could measure the vector and say, oh, okay, 2 centimeters is equal to 4 newtons, and then 1.5 centimeters is equal to 3 newtons. So I get my scale, and then I can measure my hypotenuse, and should come out again using these same numbers to be 5 newtons. And then I would take my protractor and I would extend the line and I would measure the angle, and it would come out to be 5 newtons at about 37 degrees. And this graphical method, parallelogram method, or tip to tail as I call it, doesn't have to be vectors that are 90 degrees apart. They could be at any angle. So maybe I have a vector A that looks like this, and maybe I have vector B that looks like this. And this little half arrow I'm drawing, that symbol, is one way to represent that those quantities are vectors. Could be velocity, acceleration, forces, momentum. And maybe I want to find A plus B. What's the resultant of A plus B? So I want to put these tip to tail. So I'm going to draw A, which looks something like this. Of course, on a test, you take more time to do it carefully. And then B, which is something like down here. And so A plus B, I'm going to start from the base of A, and I end at the tip of B. And so my resultant is going to be this vector here. Label it R. And then I'd measure that to get the magnitude, and then I would take the protractor and I would measure it to the positive x-axis to get the standard angle. What if it was A minus B? Well, if I have A minus B just means flip the direction of B. So I would draw in my A vector again. There's my A vector. But now I'm going to draw B going in the opposite direction. So negative B looks something like that. So now A minus B, start with A, end with B. So I'm going to start down here. I'm going to come all the way up to the tip here. And this is now my resultant. Label that R. And then I'm going to measure that standard angle. So I'm going to drop in that Cartesian coordinate system and measure that angle up from the positive x-axis. Now if I wanted B minus A, for example, now I'm going to draw B and flip A. So B looked something like this. And now negative A is up and to the right, so this is going to be down and to the left. So here I'm going to draw this guy down and to the left. So this is my negative A. So I want B minus A. Start with B, end with A. So I'm going to start here, and I would carefully draw in that vector, label it R, put in my positive x-axis, and then that angle would be the angle that I would measure. And because it's going clockwise, because it's below the positive x-axis, that's going to give me a negative angle. So when vectors are parallel, we add and subtract. When they're perpendicular, we can do tip to tail, or we can do Pythagorean theorem and inverse trig. And if they're at some angle that's not 90 degrees and they're not parallel to each other, then we have to do this graphical vector addition. Now, another thing that we need to know about vectors is how to break vectors down into their x and y components. In other words, if I had a vector that was maybe, we'll use velocity, 10 meters per second at 30 degrees, we need to be able to find the x and y components of that velocity. So if this was being launched from ground level, then velocity in the x would be this way, and my velocity in the y would be up there. So it's kind of like it makes this right triangle here, where this side is velocity in the y, this side's velocity in the x. This is just the velocity, and then because it's in the first quadrant, that would be my standard angle. So to find the horizontal component of velocity, it's the velocity times cosine theta. So where did that come from? Well, we know that cosine of the angle is the adjacent over the hypotenuse. So if I look at my reference triangle here, cosine of the angle, the adjacent is going to be Vx divided by the hypotenuse, which is just going to be V, the velocity. So when I multiply both sides by V, I get V times cosine theta is equal to Vx. And that's what I did over here. V times cosine theta is equal to Vx. So Vx is going to be equal to 10 meters per second times cosine 30. So I can come to the calculator. 10 times cosine 30 is equal to, and it's about 8.7. So my velocity in the x has a magnitude of 8.7 meters per second. And to find the y component, velocity in the y is going to be velocity times sine of the angle. So in this case, velocity in the y is 10 meters per second times sine of 30. Now I know that sine of 30 is a half, so half of 10 meters per second is 5 meters per second. So my velocity in the y is 5 meters per second. So this is how I can find the x and y components of a vector that's up at an angle. Here, this would be, in my example, that's my 30 degrees there. So we also need to know how to use this in word problems. So it's the same things that we've been going over, but we need to be able to pull the information out of the word problem. And I'm not going to write the whole thing out, but let's say I have a boat and it's going from shore to shore and it's going at, let's say, 3 meters per second. We'll use the same numbers north. So I'm going to draw a picture. Here's my boat and it's going 3 meters per second. It's going 3 meters per second to the north, and maybe the river, the current, is going 4 meters per second east. So I'm going to draw an arrow here. This represents 4 meters per second that's going east. So you can see it's similar to what we've done before, but maybe there's a picture and I have to measure this vector and come up with a scale, or maybe I have to draw in these vectors, or maybe I'm just getting the information from the paragraph. But in this case, you know, the opposite shore is over here, and this shore is over here. And the question is, what's the resultant velocity as witnessed by somebody on the shore? So in other words, we're going to add these two together. So whether I do tip to tail, right, move the 3 meters per second over here and draw it in and then measure it, or whether I use Pythagorean theorem, in either case, my resultant is going to come out to be, what, 5 meters per second at, and what was my 37 at 37 degrees, just because we did the math before, right? Where did this angle come from? If you remember, that just is going to come from the tangent of 3 meters per second over 4 meters per second. And remember, that came out to be about 36.9 degrees. And so we'd write that as 5 meters per second at 37 degrees. Yeah, so these are the most common questions that we get with vectors: adding and subtracting parallel vectors, and then finding the resultant of perpendicular vectors, doing the tip to tail method, finding vector components, and then being able to do these things when pulling the information out of a word problem.